All right. It's not like you guys aren't going to make me do this the entire hour, right?
No, we won't if you told us. No, we are. Oops, I'm almost scared.
6. Let's do 6 next. That's on our list, right?
For the other independence formula, was that a given?
Yes.
A divided by B.
That's A given B. That's a conditional probability. It's just equal to the regular probability, which means that B has no effect on A, meaning it's independent, right? Or the two events are independent.
Mr. Coolidge, can you go over the little symbol things? I don't know.
The little symbol things?
The line and the U and the N. I don't remember.
Sure.
It's right at key. Yeah, I remember.
So the cap is and. The cup is or. The apostrophe is not.
Well, on the test, did you put it as failure?
Let's look. I don't think I did. I think I used the textbook's notation. It just makes it's. I don't know. Anyways. I think those are all of them. And the P is just probability of, right?
Yeah.
Okay. So far, so good?
Yeah.
Okay. No problem. So worthwhile thing to go back and double check, right? If you don't know the symbols, it's hard to do what this is asking if you don't know what the symbols mean, right? It's perfectly reasonable. All right. It says, given that we have events A and B, where the probability of A is 7 out of 10, the probability of A union B is 9 out of 10, and the probability of A intersect B is 3 out of 10, draw a Venn diagram representing the situation. All right, where should we start labeling our Venn diagram? The intersection. Always start at the intersection. Great. How many should go in the intersection? I agree. 3 things should be in the intersection. Because it's the probability of A and B is 3 out of 10. We're going to assume there's 10 total things. 3 of them need to be in the intersection. Cool? What should be in just A?
7.
No. 4. Great. How did you get 4, Isaac? 7 minus 3. Now there's 7 total things in A, right? In our picture. Because we'd already placed 3 in A when we did the intersection. We need 4 more in just A to complete the 7. Okay? The probability of A or B is 9 out of 10. So how many should be in just B? Not 6. 2. Very good, Megan. How'd you get that? So if we look, there's 7 things already placed in A or B. So 2 more things need to be in just B, right? A or B is anything in A with anything in B. So we need 9 total things there. We already had 7 of them placed, so 2 more needed to go there. What am I still missing? 1 needs to be out here in the nether regions. Does everybody feel okay with how I drew the Venn diagram? Now it's a little tricky, right? You have to really understand what those things mean symbolically, right? But once we have this, it should be relatively easy otherwise. What's the probability of B? 5 out of 10. Any questions on how Isaac got that?
Yes.
Okay. All right. The next thing wants the probability that we're not B and A. So I would highlight to just kind of do this. So I'd start by highlighting the things that are not B. And then we'll highlight the things that are in just A. So what is the overlap there? So 4 out of 10. Is everybody okay with how I did that? So far, so good? Now, notice, what are we relying on here? What are we using to do all these probabilities? The Venn diagram that we had to make ourselves. Got to be real careful before you start doing those problems that you've done your Venn diagram correctly, right? All right, let's do the next one here. So the probability of B and not A. So again, it's an and problem, so I'm looking for an overlap. So there's B, and then not A. Oops, I want to use blue, huh? So that it colors it differently for me. And then not A is all of this stuff. So what do I get here? 2 out of 10. Again, as people are calling these out, if you're not sure, you should say something. Ask. If I'm going too fast, holler at me. Okay. So we have not B and not A. Anybody can do this with just all by their lonesome? Yeah, it's 1 out of 10, right? So again, if you couldn't see it, not A would be that stuff. And then not B would be this stuff. And the overlap there is just the 1. And then our last one. So here, probability of B given not A. We have to use our conditional probability formula to do this. Does anybody remember what that is? So that's the probability of B given not A. So this is 2 out of 10 divided by not A, which was 3 out of 10. So just 2/3. Better chance at partial credit if you make a mistake if you show the work. Sure. For a problem like BI, I don't think any work is necessary. Really, I think that aside from that last one, I don't know that any work is really necessary to show. If you wanted to, you could. You know, if you did B as, if you wrote like 2 plus 3 divided by 10 equals 5 out of 10 or 1/2 or whatever you want to say at that point, that would be fine. That's a little bit of work you could show there. Just showing like what parts of B you added up.
How many points is
60. Is everybody okay with number 6 that we did here? That was okay. Do 7 then, I guess. The apostrophe and the line above mean the same thing. Oh. I thought you meant like this. Those mean the same thing. Now, if you say like probability of A given B, that's a conditional probability. That means the probability of A intersect B divided by the probability of B. That's the probability of A if B has already occurred. Right. So if you put the apostrophe on the B, it's the probability of A given that B has not occurred. Right? All right. It says events A and B are given such the probability of A is 1/3, the probability of A union B is 4/9, and the probability of that B has occurred is 2/9. Show that A and B are neither independent nor mutually exclusive. What I would do on a problem like this is I would start by drawing a Venn diagram. How many total things should be in my Venn diagram? 9. What am I going to do with this 1/3? I'm going to think about it as 3/9. Okay. So let's look at this. How am I going to calculate the intersection? Okay, hold on. Let's before I do that. Independent, we talked about what that meant already, right? There are 2 ways to show that. Right? That you can either show that probability of A is equal to probability of A given B, or show that the probability of A and B is equal to probability of A times the probability of B. Either of those is fine. What's mutually exclusive mean? Just means that the intersection is non-empty. right? That the probability of A and B is not 0. Everybody's good with that? Now, what I would do for this question is I would do the mutually exclusive part first, because if I can figure out the probability of A and B, I can use that to show independence the other way. Or show that it's not independent using that formula. Is everybody okay with that plan? Is that okay? So, given the stuff that I have here, how can I figure out A and the probability of A and B? We've used the formula already earlier. That's the formula we need right there. So if we fill this stuff in, what do we get? The probability of A and B is 1/9. So we know they're not mutually exclusive because the intersection is non-empty. Is that okay? And then for independence, we know the probability of A times the probability of B is 3/9 times 2/9, which is, what is that, 2/27, or 6/81, either is fine. And the probability of A and B is 1/9, and those two things are not equal. Does that feel okay there? Megan, you look concerned. One second, real quick here. I don't know if this will make you feel better or not. So I don't know if that makes you feel better or not, but like this is given to you. So like don't like waste a bunch of time trying to memorize all the formulas. Okay? Does that make you feel any better? You looked really concerned about like the formula piece.
I really didn't know.
Yeah, that's okay. Does that helps a little?
Yeah.
Okay. So I'll leave that in there so you guys, when you're practicing, you're like, ooh, that's not on the list. I better make sure I memorize that thing. But I think for the most part, like, everything you need is there. But I'll put that in there so you guys can look at it. What did we just do? We did 7. All right, let's do 20 or 21. All right, so an athlete is shooting arrows at a target. She has a record of hitting the center 30% of the time. Find the probability she hits the center A with her first or with her second shot. Should be really, really easy. Nope. Doesn't need to hit the first and second shot, which is what you've written, what you've given. Just 3 out of 10, or 30%. Right? It's in that second shot, probability of hitting is independent of what happens before or after. It doesn't matter. It is wholly independent. The probability of hitting the target with any shot is 30%. Now notice the wording has changed. All right. These problems here can be really tricky to think about. So I'd really like your full undivided attention here while we kind of talk through how to think about this kind of a problem. So we have 3 shots. We want to figure out the probability that we hit the target exactly once in those 3 shots. How many different ways can we hit the target once in 3 shots? So 3 different ways, right? You can go target, miss, 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 target, miss, or miss, miss, target. 3 ways, right? Everybody agree with that? So what we're going to do So there's 3 ways to hit the target once. And now we're going to calculate the probability of just hitting the target once. Everybody's okay with that? So we need 1 hit and then 2 misses. Well, the probability of hitting is 30%. The probability of not hitting has to be 70%. So that's where the 0.7 is coming from. So that would be my answer. Again, you grind that through your calculator or whatever, but like that's the idea. Is everybody okay with how I thought about that? This is the part that most people forget. Now, you could have thought about this as like 0.3 times 0.7 times 0.7 plus 0.7 times 0.3 times 0.7 plus 0.7 times 0.7 times 0.3. You get the same answer. You could think about it that way if you prefer. I like doing this way because it's just like less writing. But still giving you the same thing, which is exactly what we described in the beginning, right? Hit, miss, 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 hit, miss, 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 hit. And add those three up. You could do it that way also. Is that okay? Part C says, at least once in our first 3 shots. So at least is greater than 1. So this would mean probably of exactly 1 hit plus the probability of exactly 2 hits and the probability, or plus the probability of exactly 3 hits. Ugh. That looks like a lot of work. Or what's the other way you could think about it?
Just get one.
We could think about it as a complement, right? Which that is equivalent to 1 minus the probability of 0 hits, right? That you're getting not exactly 1 hit, which would be, or not at least 1 hit, which means less than 1 hit, which means 0 hits, right? That seems like the better way to go to me. Do you guys agree? Now, you could do it the other way. It's a lot more work, more calculation to find, but it's not wrong. What's the probability of getting 0 hits? Well, miss, miss, miss. 0.7 times 0.7 times 0.7. What do you guys think on that? Is that okay? And again, that's like the complement formula there, which is basically this, right? It's like P of not A equals, and then we subtracted P of A over to the other side. So we have 1 minus P of A. So it's that same formula, just been rearranged a little bit. Just showing you that it's on the equation sheet, but not exactly in the form that we used it. Now we've done a bunch of examples now of like the kinds of things you should be able to do on the test. Which one of these skills would you like to do again? Okay, so I'm going to ask you guys to take your stuff out, work on 23. We'll give you like 10 minutes or something, and we'll go through it as a group. Deal? Seems fair, right? Get you a little bit of practice now that you've seen examples of like how to do some of this stuff. You have some primer to work from. I'll put the question on the board here for us so you don't have to like pull out a book or anything, because I know that's kind of a hassle. Before you leave today, you should turn in your activity, absolutely. You could do it right now if you want, or you can just dump it on my desk on your way out of the room. Either is okay. So again, this is a tree diagram one, absolutely. This one's a little bit meaner because you're not given the tree diagram to fill the blanks in, but Thanks, Christian.
Yeah.
I just stapled it to that.
Yeah, that's fine. No big deal. I know you had some erasing issues. No biggie.
Oh my God. It's so
Thanks, Elise. Yeah, of course. Correct. 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 No second semester final.
So no penalties if I miss more than 3 classes.
I don't think so.
It's 5. I thought it was 3.
I think it's 5.
Not that I missed school.
My leg was on it. So, like, what happens if you, like, miss more than 5 classes in an AP class and they're not going to give a final?
I don't think anything.
Ooh!
I know.
Econ might be
Oh, today's econ was Mr. Cliff, what's our IB test?
not be late for the meeting.
Ooh, that's a good question. I have to look that up.
Yeah, bro. But it's not
So much more. It's like
they're not the same. Let's just say that.
Does it matter on April 1st? I said no one cares. No, I don't think there's no Let's wait. Let's go. Can you scroll up? Yeah, just. Oh, he's not late. That's not good. Oh, he made it on time. This is the probability. It's just one form. Because that's a chance he given that he made it on time. That's not true. That's not true. It's given. Because even if this flight's canceled, you can still not be late. Yeah, but I think it's given you made it on time. Find out the probability. That doesn't help at all. Oh, because if he drove, he wouldn't be there the same day. It doesn't matter. So I think if it's on the same day, that means he took the point. If he drove, it would be the next day. Yeah, yeah. No. Okay, yeah, that makes sense. I don't have a formula though. Yeah.
Yes.
Wouldn't the probability of one airplane just be 4 out of 10?
The probability what?
Proceed.
Given that he was not late,
Oh, I thought those were C.
right? It says on April 1st, Brian made it to the meeting on time. Find the probability they went by airplane. So that's probability went by airplane given that we were not late.
Oh. So like 5%.
So that's a conditional probability there.
We're always going to the goals. No, we're not.
I think is how you should do that. Check. Oh, am I doing the looking at the wrong thing? Oh, that's okay. You know what, guys? I was looking at the 8-3 problems, but it's fine because those 8-3 problems match up pretty nicely. I grabbed the wrong thing, so that's whatever. Yeah, I hope so. Hold on 1 second, though. Oh, my goodness, guys. Those were in the wrong spots. I just read the problem wrong. I was like, why isn't my answer matching up? I'm like, I know I did that right. It would make sense because I drew my Venn diagram, or I drew my thing wrong. There we go.
Well, I had the equation, but I could share.
Yes.
For the trigger diagram on the bottom, it says, yours says it's 75% chance it's late. I think it's supposed to be 75% chance it's not.
Yeah, then they're yeah, I think you're right. And the textbook answers then are all wrong in the back then. Because they flipped it. I was like, I swear I did this right. And then I checked the answer in the back of the book and it's like, oh, you're wrong. And I'm like, am I really? Okay. It's like, oh, look, I just misread this and put them in the wrong spots. It's like, oh no, I didn't misread anything. Your editors are just terrible and they somehow managed not to catch the thing. Yeep. So here, just FYI, guys. So again, what I noticed here is I was looking at the 8-3 homework, when I was pulling the questions based on the test rather than the review. So the problems that we've just been doing have been the 8-3 problems. Somebody should have noticed that and been like, we did these already? This looks like the 8-3 homework, Mr. Gulick. But I give you a pass on that because it's been a while. Or you just copied it all out of the back of the book because it was like the week of final exams and you just didn't care. Not saying that any of you guys would ever do that, but do you guys feel any better about what you have to do after this?
Yeah, I forgot everything.
You forgot everything. They just like refresh our memory a little bit. Yeah, like do some practice, right? The test is next class. Do some practice. If you have questions, come back and find me. I'll be in CT, right? Tomorrow's probably a good day to catch me, or so feels like with 5 minutes left is a good time to stop.
Wait, this is going to be on
What?
OneNote?
Yeah, it's all in. This is all in OneNote right now that you're looking at. So hopefully this was pretty helpful. Again, I tried to be like really specific about how we did things and why we did things, and like converting words to symbols and talking about what the symbols mean, and that helps. That helps.